Hello, my name is Isaac. I'm a tutor at CWI, and today we're going to be working through practice exam 2 for Physics 212. Right now I'm on problem number 5, and it states that an electric current is given by the expression I of t is equal to 100 sine of 120 pi times t. Here I is in amperes and t is in seconds. What is the total charge carried by the current from t equals 0 to t equals 1 over 240th of a second? And so the important breakthrough here is that we can write current as the change in charge with respect to time equals 100 sine 120 pi t. Now what we really need to look for is we need to look for the derivative with respect to time of some function q that's going to give us 100 sine of 120 pi t. Alright, and how do we find the opposite of the derivative? We're going to integrate both sides with respect to t. And what will our bounds be on this side? Well, our bounds are going to be in terms of time, so it's going to be the time initial to the time final. So we're going from 0 seconds to 1/240th of a second. And the integral of the derivative with respect to t of q of t is just q of t. And then we just need to evaluate this integral. In order to do that, we can get rid of the constant out front. We could write this as 100 out front, 1 over 240 for the bounds, sine of 120 pi t dt. And then for our u, for u sub, we're going to choose 120 pi t. Now you don't really need to do u sub. It would be pretty simple just to divide by what's on the inside here for the result, but I like to use u sub whenever I can. That way there's less thinking. So du is going to be 120 pi dt, and so if we want to substitute something in for dt, it's going to need to be 120 pi underneath of du. So with that substitution, we end up with sine of u du, and then on the outside we have 100 divided by 120 pi. And now we're going to go ahead and take the integral of this. The integral of sine of u is negative cosine of u, which we can then resubstitute this in for u, 120 pi t. And all this is multiplied by 100 over 120 pi. There's a minus sign out front, and we're evaluating it from 0 to 1/240th of a second. Alright, so now at this point it's just plugging and chugging. We'll start with the upper bound. 120 divided by 240 is going to be 1/2. So that's going to give us pi halves in here. Cosine of pi halves is 0. So that's going to multiply through and create a 0 here. So for our first evaluation we have 0. Then we're going to subtract the second evaluation, which 0 times anything is 0. Cosine of 0 is 1. And so we're just left with this part left out here in front. 120 pi. And 0 minus a negative 100 over 120 pi is going to be a positive 100 over 120 pi. And so that's going to be our charge that is flowed through this circuit from time equals 0 to time equals 1/240th of a second. And maybe we'll even round it out. 100 divided by 120 divided by pi is roughly 0.265 of a coulomb. And so that's how we solve for the amount of charge that's flown through a circuit if we know its current as a function of time. Just remember this, we can write I as dq dt, and that's a very important trick to have up your sleeve. So hopefully this was helpful, and I'll see you next time.